Kadi Artillera. Today, I'm going to tackle one of the technique and testing the reliability of assessment method, which is the split half method. So in this method, we're going to learn what is split half method is used for. What are the steps or procedures we are going to do? And what formula that we should apply in this method. Split half method assesses the internal consistency of the test. It measures the extent to which all parts of the test contribute equally to what is being measured. When we are talking about internal consistency, it is an assessment of how reliably a survey or the test items that are designed to measure the same construct. For example, if a respondent express agreement with the statement, "I like to ride bicycles," and "I've enjoyed riding bicycles in the past," and disagreement with the statement, "I hate bicycles," this would be indicative of good internal consistency of the test. For addition, split half method is commonly used for multiple choice tests and any type of test. Split half method is a test for a single knowledge area split into two parts and then both parts given to one group of students at the same time. To split the test into halves, the usual procedure is to divide the test questions into odd and even number or items. Then score them separately to estimate the reliability coefficient. When we say odd number, it is the number in the test items 1, 3, 5, 7, and 9. An even number is 2, 4, 6, 8, 10, and so on. However, the reliability coefficient, it means a way of confirming how accurate a test or measure is by giving it to the same subject more than once and determining if there's correlation, which is the strength of the relationship and similarity between the two scores. Since the reliability coefficient holds only half of the test, the reliability for a whole test is calculated using the Spearman-Brown Formula. And for the half test, it is calculated using the Spearman Rank Correlation Coefficient. Spearman-Brown Formula is also known as Spearman-Brown Prophecy Formula. It provides a rough estimate of how much the reliability of test scores would increase or decrease. Spearman Rank Correlation Coefficient is a statistical measure to show the strength of a relationship between two variables. To better understand this method, here is an example and the following steps. For instance, a test that has 160 questions is administered to 14 students from different institutions. The test questions is related to statistics subject. To determine the reliability coefficient of odd and even items by using Spearman-Brown Formula and Spearman Rank Correlation Coefficient. Here are the following steps to measure the split half reliability of the test. Step 1. Split the test in half based on odd numbered and even numbered questions. Step 2. Administer each half of the test to the same individual. Step 3. Repeat for 14 individuals. Step 4. Check the test and get the scores between half of the test. As you can see in the table, it is the test results or the scores obtained from 14 students between half of the test. Each half of the test has the total of 80 items. The highest scores in odd items is 75, while the highest score in even items is 76. Step 5. Rank the scores or the odd and even items of the test obtained from 14 students. In this data, we have here 14 students and the scores of odd and even items or the X and Y. So we're going to rank the highest to lowest scores of odd and even items. So the highest score in the odd items is 75. Next is 73. We are going to rank 2. Next is 70. We are going to rank 3. Next is 64. But when you look at carefully in the number 9 student and number 12 student, which is they have a tie score. So they are supposed to be rank 4 and rank 5. So in this case, we are going to 4 plus 5. So we have two numbers. We're going to divide to 2. 4 plus 5 equals 9 divide 2. So 9 divided by 2 equals 4.5. So we are going to assign the two ranks of 4.5 and 4.5. So we're going to find the 6th highest number, which is 60. So we're going to rank 6. Next is 52. We are going to rank 7. Next is 45. We're going to rank 8. Next is 42. We're going to rank 9. Next is 40. We're going to rank 10. Next, 35. We're going to rank 11. Next, we're going to find the rank 12 is 33. We're going to assign 12. Next is we have to find the rank 13, which is 31. We're going to put it 13. And the lowest number, which is 21, we're going to rank 14. So again, we're going to rank the highest number of even items, or the Y. So we're going to find the highest number, which is 76. We're going to rank 1. We're going to find the rank 2, which is 71. We're going to 2. Next is 67. We're going to rank 3. Next is 66. We're going to rank 4. Next is 64. We're going to rank 5. And 62. We're going to rank 6. So again, we're going to find the rank 7, which is 50. But when you look at carefully, student number 1, student number 4, and student number 11 have tie scores. So they are supposed to be rank 7, rank 8, and rank 9. So we're going to do in this case, we should 7 plus 8 plus 9. So they have 3 numbers. We're going to divide to 3. Equals 7 plus 8 plus 9 equals 24. Divide 3 equals 8. So we're going to assign to the 3 ranks with 8, 8, and 8. So again, we're going to find the rank 10, highest number of even items, which is 48. 48. Going to have rank 10. Next, we're going to find the rank 11 is 45. 11. Next is 43. Rank 12. Next, 38. Rank 13. Next, the lowest number is 32, rank 14. Step 6. Find the difference between the two ranks of odd and even items. So next, we are going to find the difference between the two ranks. So, 7 minus 8 equals negative 1. 10 minus 13 equals negative 3. 3 minus 3 equals 0. 11 minus 8 equals 3. 8 minus 10 equals negative 2. 2 minus 6 equals negative 4. 12 minus 12 equals 0. 1 minus 5 equals negative 4. 4.5 minus 4 equals 0.5. 13 minus 11 equals 2. And 9 minus 8 equals 1. And 4.5 minus 1 equals 3.5. 14 minus 14 equals 0. And 6 minus 2 equals 4. So, negative 1 times negative 1 equals 1. Negative 3 times negative 3 equals 9. 0 times 0 equals 0. 3 times 3 equals 9. Negative 2 times negative 2 equals 4. Negative 4 times negative 4 equals 16. 0 times 0 equals 0. Negative 4 times negative 4 equals 16. 0.5 times 0.5 equals 0.25. 2 times 2 equals 4. 1 times 1 equals 1. 3.5 times 3.5 equals 12.25. 0 times 0 equals 0. And 4 times 4 equals 16. So, 1 plus 9 plus 9 plus 4 plus 16 plus 16 plus 0.25 plus 4 plus 1 plus 12.25 plus 16. So the summation of this squared is 88.5. Step 7. Compute the reliability of half tests using the Spearman Rank Correlation Coefficient. To get the reliability of half tests, we are going to use the Spearman Rank Formula, which is reliability of half tests equals 1 minus 6 summation of d squared divided by n cubed minus n. 6. So the summation of d squared is 88.5. N represent the number of students. 14 cubed minus 14. 6 times 88.5. 6 times 88.5 is equals to 531. 14 cubed, 14 times 14 times 14 is equals to 2,744 minus 14. So 2,744 minus 14, 2,744 minus 14 is 2,730. 531 divided by 2,730. 531 divided by 2,730 is 0.194 9. So we're going to subtract this. 1 minus 0.1945054.9. So it is equals to 0.80. So this is the reliability of half test. Step 8. Compute the reliability of whole test using the Spearman-Brown formula. To get the reliability of whole test, we are going to use the Spearman-Brown formula, which is reliability of whole test equals 2 times reliability of half test divided by 1 plus reliability of half test. So RW. So 2, the reliability of half test is 0.80. 0.80. 0.80. 2 times 0.80 is 2 times 0.80 equals 1.6. Then 1 plus 0.80, 1 plus 0.80 is 1.8. 1.6 divided by 1.8 is 1.6 divided by 1.8 is 0.88. So this is the reliability of whole test. The foregoing reliability of half test is 0.80 and reliability of whole test obtained is 0.88, which denotes very good relationship. This means the reliability of whole tests between odd and even items of achievement tests has very good reliability. What is good reliability coefficient? A coefficient of 0 means no reliability, and 1.0 means perfect reliability. Generally, if the reliability of a standardized test is above 0.80, it is said to have very good reliability. If it is below 0.50, it would not be considered a very reliable test.